Development trends in DC. Our project summary is that to explore gentrification and redevelopment trends and the outcomes of what they have on the DC community. We will do this by examining the specific land use, areas undergoing redevelopment, and affordable units within the area. We found this important because we want to learn what the land is being used for in DC and if there are affordable units on the land. Our results will show the overall trends of redevelopment in DC and if there is affordable units within those areas being developed. Our data was collected by an open data source for DC data. First, the data set was an existing land use in DC. It records the land use for now and what the land was used for before. We decided to use this data set to make a comparison to find out what's interesting trends of redevelopment over time. The second data set was the Washington, D.C. Economic Partnership, or the WDCEP. The redevelopment in DC, we decided to use the data set to see the trends of development plans in DC and the future outcomes of what could possibly occur. The last data set we found was affordable housing in DC. We chose this data set to see the plans of affordable housing and redevelopment plans in the DC area. Data wrangling and cleaning. Most of the cleaning was revolved around dropping unnecessary columns in data, blank data sets, null values, and data frames were created. These data frames were created to hold a certain columns within the data set that we found important to explore our decision. Aggregation was performed to get a certain sums and outcomes throughout the data to explore trends. Now I'll hand it over to explore the trend of redevelopment.
Our first data analysis is based on you explore the trend of redevelopment. And the data set is came from the open data and is the existing land use in this area. So we want to compare the land used for now and the land used before. So we can see the trend in this area. So the first step is clean the data. We import the data from the open API, from the open data, and we can see it's really a mess. But we only want the land used for now, which is this one, and the old land use. So we perform the column deleted, and we rename the code in the data set. So after that, we can get a clean data, which is this one. Then we want to do the analyze part. So we want to give an overall comparison so we can see how different facilities have those units in it. So this one is the land used before, land used for now, and this one is land used before. And we combine that in a diagram. We can see that the land used before, most of them are undetermined, and for now, those undetermined lines are used for different purposes, and we can see overall increasing in the different facilities, and so we can see this trend is like is going up. All the facilities are going up and used in the different facilities. And the second step, we want to get a trend in different words, in different areas. So we perform a pivot in the by using the word ID, so we can get this chart here. So we can see the word ID is 0 to 8, and there are different facilities in the world. And this chart is the current land use. And we can compare with previous land use and in different world. So by comparing them, we can see we can see the undetermined land used in different world, and we can see how they goes into the current land use. For example, we can see for word ID 0, most of the line are going to the transportation right of way. The third step, we can calculate the area used for different facilities. So by doing that, we can see how exactly the area used in the different facilities. And by observing and this is the land use for now, and that's the total area, and the land use before, and this all the area used for different facilities. That also proves that opinion that the trend is for different facilities are going up, that the total area are increasing, and the total area for the undetermined are decreasing. So we create a visualization for this data analyze, and this is my visualization. And for now, we can see that uh, the visualization proves that all the facilities have a trend that's going up. Uh, then we will talking about the second data set, and it will be performed by Richie. I will give his video, and he will talk about it.
This notebook file is analyzing the WDC EP development report. It is a summary of the major development and construction project in Washington, D.C. from 2016 to 2020. This dataset is downloaded from the Open Data DC. But first, we use the Panda Read CSV to import the dataset. For data cleaning, there are a lot of columns that are not related to our topic, so I remove those columns and rename some of them. I printed out the total count for word, status, and project types. I discovered that there are only 3 types of status, which could representing the old land, new land, and the further land. So I replace the name of each rows for status and save to a new CSV file for the further visualization. We also want to calculate the total area for each type of land. So I removed all the columns except the status and the square foot. I used the 0 to replace all the null value and did the calculation. And this link is a Tableau visualization. And the first graph is related to word and square foot. We can see that the word 2 and word 6 has the most area of new land and the future land. The second graph is about the project type. All of the development are not for the residential in this graph, and the most of the development area are used for office. And the last graph is compare the status and the project type by area. The new land has are the most used for the hospital and the office, and only a small part of area are used for education.
Okay, so for the last data set we used affordable housing in DC data set, also found in the Open Data DC website, is the affordable housing production preservation projects in Washington, D.C. So first, before importing the data set into Jupyter, I used OpenRefine to do a little data cleaning where I renamed some certain columns and removed certain cells. So I went ahead and uploaded it after that. And then I wanted to go ahead and drop the NA values to continue cleaning the data set. So then what I first did with the data is that I aggregated to get the sum of the number of affordable units for each development status, which was either completed in 2015, pipeline, or under construction still. So these are the affordable units. Most of them are in pipeline. So then I went ahead and aggregated to get the sum of the number of affordable units per ward. So as you can see that Ward 6 has the most affordable units and Ward 3 has the least amount of affordable units. So then I wanted to graph both those aggregations. So the first graph shows the total affordable units per status, and then the second one shows the total affordable units per each ward. So then I wanted to go ahead and merge this data set with the second data set, the development plans data set. So first I took the development plans data set and I only included the ward and units columns. And then I aggregated to get the sum of the units that are being developed and developing in each ward. And then I wanted to merge that with my aggregation with the total affordable units per each ward to see how many affordable units are available at each ward that is being developed. So I went ahead and merged it using an add or join. And I also filled any NA values with 0. So then the first visualization is a subplot of both graphs. On top is affordable units per word, and on the bottom is the developing units per word. So as you can see, there are more developing units per word compared to the affordable units per word. I went ahead and wanted to do another visualization of this data. So I plotted on one plot. On the left is the total number of affordable units, and on the right is the total number of developing units. So as you can see, there is not a lot of affordable units at each ward, but there have been an abundance of developing and developed units. So for the analysis overall, we discovered that residential land use in DC has been increasing, particularly single family units. Looking at the development plans graphs, we can see that there's a huge amount of land being developed and have already been developed. Taking a look at the affordable units in that developing and developed land at each ward, there are only a fraction amount available. We did expect this outcome because we have experienced seeing all the new buildings in DC and the talk of redevelopment and pushing people on gentrification there. Because now, like, DC is so expensive to live. There are limits to our data. However, since some of our data was removed in the cleaning process and only certain years were included, there's also lack of data on factors considering gentrification, such as population, income. So our question was slightly answered since we did discover trends in development, but we cannot conclude gentrification is present in DC. So what would we do differently if we had more time? If we had more time, we would have wanted to analyze the percent population and population income in Washington, D.C. prior and after development. We wanted to do this to see if development had an effect on the types of population and population income in D.C. to ultimately answer part of our research question of gentrification in D.C. So additional resources that we would need to integrate in order to solve that. We would have wanted to integrate the poverty status variables track data set found in Open Data DC. This data set shows the percent population and population income in Washington, D.C. We would have wanted to use this data set to discover the trends between population income in D.C. and explore how that relates and compares to the development trends in D.C. that we have discovered. And that is all. Thank you.